NASA confirmed Thursday that the Voyager 1 probe has made history by becoming the first human-made object to leave our solar system and enter interstellar space. NASA engineers assigned to the Voyager mission have been freaking out about something. The alarm bells have been coming from Voyager 1, which has been sending messages that have perplexed them for months. Liftoff of the Delta rocket carrying glass searching for unseen physics in the stars of the galaxies after more than 45 years in space. NASA is now warning about the totally unexpected discovery made by Voyager 1. What has Voyager 1 discovered and why is it so shocking? Stay tuned as we bring you the warning by NASA about the impossible discovery made by Voyager 1 after more than 45 years in space. On August 25, 2012, a very important record was set, even though it went unnoticed by the majority of the human population. For the first time ever, after a journey that took 35 years and covered a distance of more than 11 billion miles or more than 18 billion kilometers, a human-made object crossed into what is known as interstellar space. This is the spacecraft, the first interstellar space, we made it. The object was Voyager 1, one of the inventions that NASA is most proud of. Interstellar space is special in astronomy. It is the environment between stars. It is a region where solar winds, the stream of highly charged particles flowing out of the outer layers of the Sun's atmosphere, no longer have a significant impact on the cosmos. The region where this happens is known as the heliopause. This is the very region where the Sun's wind collides with the winds from other stars. In other words, the cold vast regions where the influence of other stars is felt. The only other human-made object to cross this boundary is, you guessed right, Voyager 2, but this happened a whole 6 years later. To achieve this feat, Voyager 1 had been traveling at a mind-bending speed of 37,000 miles per hour or 325 million m per year. To understand where Voyager 1 is presently, here is a succinct description of the far, far away region it is in. Imagine the heliosphere as a bubble shaped like a bullet surrounding the Sun. The Sun blasts off solar winds from its surface at about 179 million miles per hour. These hot, highly charged particles escape into space, filling up the void with ionized gas. This is known as heloplasma. These solar winds, however, eventually slow down and come to a halt when they encounter interstellar space, where they find denser, cooler plasma from particles formed when stars exploded some 15 million years ago. The heliopause is practically the boundary of our solar system. When the Voyagers began their mission in 1977, scientists thought the boundary was somewhere just on the other side of Jupiter, some 365 million miles from Earth. But they actually had no idea how massive the Sun's bubble was. One of the most shocking discoveries Voyager 1 made in interstellar space is measuring the density of the interstellar medium. According to the data collected by the spacecraft, the particles in this space were higher in density compared to the outer regions of the heliosphere. The instrument that took the measurement was the plasma wave science, which detected electron density through the vibrations of plasma waves. Scientists actually expected the moment Voyager 1 crossed into interstellar space to be like a bleep, but they would learn that the boundary was much thicker and more complex than they thought. However, what they learned and observed from Voyager 1 was confirmed 6 years later when Voyager 2 also crossed the boundary. The scientists in charge of the mission were initially confused by the magnetic field data sent back by Voyager 1. They were expecting something different, like a noticeable change where the magnetic field of the Sun encountered the magnetic field from space. But they were shocked when the spacecraft did not detect any changes in the magnetic field direction. Voyager 1, however, has developed a problem that threatened to bring the decade-long mission to an end. This was not the first time the spacecraft had run into problems, but the mission controllers were fearful that this might be the curtain call. What is wrong with this darling of the world of astronomy? Simply put, Voyager 1 has developed a memory problem. Many of us forget things on a daily basis with no serious consequences to our well-being. However, when you are located billions of miles from the Earth, memory problems could be faced. For Voyager 1, it could mean NASA has heard from it for the last time. The space agency has spent months troubleshooting the aging spacecraft after it started sending back gibberish information. It led to a pause in the scientific work that Voyager 1 supports as the maintenance team tried to track down the problem. They have examined the flight subsystem, which is the computer unit that instructs the telemetry modulation unit to transmit data back to the Earth. From early findings, the culprit might be a single chip, which is part of another component known as the FDS. This possible breakthrough was achieved after NASA engineers sent out an instruction that prompted Voyager 1 to transmit back a readout of its FDS memory. The team then discovered that about 3% of the FDS memory had been corrupted. This was preventing the computer from functioning properly. What complicates the issue is simply age. Most of the devices we use are not designed to last more than 50 years, and when they have to operate in the harsh environment of space, it is nothing short of a miracle that these machines are still functioning. You also have to consider that many of the people who built the spacecraft are no longer around. Others, among them, have moved on to something else or retired. Something else complicating the diagnostic process is distance. Currently, Voyager 1 is more than 15 billion miles away from the Earth. If you send out a signal to Voyager 1, it takes 225 hours, almost a day, for the spacecraft to receive it. The same is true when the spacecraft responds with its own message because the engineers have to wait 225 hours to get the message. It is like carrying out a conversation where you can only speak a single word per day. Engineers call it troubleshooting in slow motion. This makes the work of looking for the issues more or less educated guesswork. They can't even say with certainty what the issue is. They have suggested the chip in question was hit by an energetic particle from space or the chip simply wore out after more than 45 years in service. The most frustrating aspect of this latest Voyager 1 crisis is that, based on the data available, the spacecraft simply can't figure out how to send the correct message back to Earth. It is functioning as fine as it could, but its communication with the Earth is hampered. To get to the root of the problem, NASA had to rouse an engineer from retirement. Bob Rasmussen started his career right out of school 2 years before the Voyagers took off and had worked on and off the mission before calling it quits. However, the allure of fixing the problems of an old buddy brought back the engineer. He was involved in another communication issue the spacecraft had and decided to stay on to fix any future problems. Rasmussen and his colleague had their job cut out for them as they needed to understand the spacecraft as much as possible. This meant they had the tedious job of going through the original design schematics, which by this time consisted of papers that had yellowed and were pinned to various walls in the premises. The engineers likened it to archaeological digging. In their diagnosing procedure, they would send commands once a week to Voyager 1. They usually send the messages on Friday and hear back on Sunday. The progress was slow, causing even more frustration. However, they are not giving up, not even among the senior leadership level team. The breakthrough mentioned earlier came in March when they examined one of the responses from the spacecraft. In the place of the garbled message they had been getting, Voyager 1 sent back a string of numbers that looked familiar. That was the Rosetta Stone moment, and one of the engineers quickly learned to understand the jumbled language that Voyager 1 now communicates with. A part of the response that was familiar revealed it originated from the FDS memory. The next issue was whether they should resign to using the new corrupted way Voyager 1 was communicating or whether it was possible to fix the glitch and return Voyager 1 to its original state. In space exploration circles, few Voyagers come close to Voyager 1 and Voyager 2 in terms of legendary status. When they embarked on their deep space scientific journeys almost 5 decades ago, few people could imagine the next generation of space scientists would still be mining data from them. The twin mission sponsored by the National Aeronautics and Space Administration NASA was originally to explore the furthermost planets and the outer limits where the sun's influence stops. However, the Voyagers have over the years managed to push the boundaries of humanity's knowledge of deep space into territories never imagined possible. Well, let's move ahead to the launch period. John, I understand you made the decision to launch the first one and call it Voyager 2, which confused all of my brethren in the press as to why you would launch despite the naming convention. Voyager 2 took off first. It was launched from Cape Canaveral, Florida, on August 20th, 1977. The launching vehicle was a Titan Centaur rocket. Voyager 1 took off on its own spectacular journey about 2 weeks later, on September 5th, 1977. Voyager 1, however, was able to reach its planetary targets faster because it launched on a faster, shorter trajectory. Even though they might have been overtaken by modern inventions, the Voyagers were a marvel of their time. They carried onboard sophisticated modules that allowed them to study, record readings, and transmit them back to the Earth. The Voyagers were crammed with instruments that studied the atmosphere, studied the planets, and also took dazzling pictures of them. Some of the tools used for observations on the twin probes include a magnom for measuring the strength and direction of magnetic fields, sensors that monitored the electric fields, detectors for studying plasma waves, instruments for looking at cosmic rays, and other apparatuses for studying low-energy charged particles. As for pictures, the Voyagers packed some powerful cameras. They both carried an identical imaging system composed of 2 television-type cameras and 9 other optical devices. One of the cameras was designed to take narrow-angle shots with a longer focal length, and the other was fitted with a wider-angle lens. The cameras used a color filter system. Each camera was fitted with 8 filters to record specific wavelengths of light. The cameras were attached to an electronic unit that processed the data and sent it back to the Earth, where the images were processed into stunning pictures. The Voyagers also carried a device for measuring infrared radiation, which helped the spacecraft study the chemical compositions of the atmospheres and surface temperatures of the planets they studied. The detectors used to study ultraviolet light allowed the Voyagers to study the upper atmospheres of the planets as well. In order to understand the atmosphere of the planets, the Voyagers sent radio waves which bounced off the atmosphere and were picked up by ground-based stations on the Earth. This provided data on the temperature, pressure, and composition of the atmosphere. There was also a photopolarimeter that used a telescope to collect light and measure its intensity and polarization. This device allowed the Voyagers to study the physical properties of the clouds, aerosols, and the surface texture of the objects they came across. We mentioned that the Voyagers took dazzling images of the planets they studied. The most popular photos were from a sequence of shots showing the Earth and Moon together in a single frame. The Voyagers took these images on September 18, 1977, as part of the first test of their camera system. This provided a unique perspective of our home planet from space and a stark reminder of the vastness of space. The spacecraft took other memorable pictures of the planets. For instance, they snapped the first high-resolution images of Jupiter and its major moons. These images provided unprecedented views of the Great Red Spot, a massive storm in Jupiter's atmosphere. They also revealed intricate details of the planet's cloud formations, including swirling storms and dynamic cloud bands. The Voyagers did not just stop at Jupiter. They also took close-up pictures of Saturn. Saturn, with its mesmerizing rings, was another fascinating subject for the Voyager probes. These spacecraft captured stunning images of Saturn's rings, revealing intricate details of their structure and composition. The rings appeared as a series of concentric bands, each composed of countless particles ranging in size from tiny dust grains to large boulders. Voyager's cameras also captured close-up views of Saturn's moons, including Titan, the largest moon, which has a thick atmosphere and hydrocarbon lakes on its surface. The Voyager probes not only provided breathtaking images of the planets and moons but also conducted valuable scientific experiments. They measured the composition of planetary atmospheres, studied magnetic fields, detected cosmic rays, and observed interactions between the solar wind and planetary magnetospheres. These observations revolutionized our understanding of the outer solar system and laid the groundwork for future missions to explore distant worlds. Despite being launched over 4 decades ago, the Voyager probes continue to transmit data back to Earth. Their longevity and resilience have exceeded all expectations, surpassing their original mission objectives by orders of magnitude. Voyager 1 and Voyager 2 have become enduring symbols of human ingenuity and exploration, inspiring future generations to reach for the stars. As Voyager 1 ventures into interstellar space, it carries with it a golden record containing sounds and images representing Earth's diverse cultures and languages. Intended as a message to potential extraterrestrial civilizations, the Voyager Golden Record encapsulates the essence of humanity and serves as a time capsule of our planet's history and culture. It is a testament to the boundless curiosity and creativity of the human spirit. Meanwhile, Voyager 2 continues its journey through the outer reaches of the solar system, providing valuable insights into the dynamics of gas giants like Uranus and Neptune. Its trajectory has taken it on a grand tour of the outer planets, allowing scientists to study these distant worlds up close and uncovering mysteries that had long eluded observation. Back on Earth, the dedicated team of engineers and scientists continues to monitor and communicate with the Voyager probes, ensuring that they remain operational for as long as possible. Despite the challenges posed by aging hardware and the vast distances involved, the Voyager mission persists as a shining example of international collaboration and scientific excellence. Looking to the future, plans are underway for new missions to explore the outer solar system and beyond. These missions will build upon the foundation laid by Voyager and expand our understanding of the universe. From the icy moons of Jupiter and Saturn to the distant exoplanets orbiting other stars, there is no shortage of mysteries waiting to be uncovered. In conclusion, the Voyager probes have transformed our understanding of the solar system and beyond. Their groundbreaking discoveries and iconic images have captured the imagination of people around the world and inspired a new era of space exploration. As they continue their journey through the cosmos, the Voyager probes serve as a reminder of humanity's insatiable curiosity and our collective desire to explore the unknown.